8.2. Pretty much our first and only lecture on deployment. Why do we not talk about deployment so much in this course? Well, there's only so much time. The point of deployment in this course is to make you aware of it and where it fits in, not to get comfortable with it. That's something else you can learn down the line. So, why are we talking about this today? The purpose of most software is not for it to exist in a vacuum, to sit on your shelf. The purpose of most software is to make it available for usage by other people. Why do you write software if no one uses it? It doesn't need to be, like customers on the App Store. It can be, clients or CSE, right? Like CSE has software that they write that helps them manage things, like Web CMS 3. You're all just a few thousand CSE, not you, you're one, but there's a few thousand CSE students who want to use that software. So CSE needs a way to not just write the code, because I'm pretty sure it's written in Python on the back end, but to actually give it to you, to make it available to you. So there's a lot that goes into this, and again, it's not fundamental in the course, it's just certainly a really important aspect of it. Now, what we're talking about today in particular is this idea of continuous delivery. Wait, is that? One sec. I think there is a slide the wrong way around. Damn it. Very quickly fixed it. I was like, really, I don't know if you can see my brain going off. It was like, what is happening? This doesn't make any sense. That slide is just like a couple slides too early. Just change that really quickly. Get it done with. Yep. As suspected, let's try again. Okay, so starting off, what are we doing in this lecture? All of that kind of standard stuff we just covered. And then we have software, deployment, which is what we're talking about now. Now, as part of the SDLC, requirements design, development, testing, and when you're all happy with it, when you're like, this is okay, you actually deploy it. The definition of deployment, which I think is a great definition, is its activities relating to making software available for use. It's taking it from a Git repo, for instance, and making it available to other people. And that is a small part of your iteration 3. It's just a bit of fun. Justin says, I don't know, some people make software for fun. It's called pure software. That's a funny description for it. Yeah, some people do write software for fun for no reason other than it's fun. What this course kind of focuses on is, I guess software in the context of software engineering, and software engineering is focused on, building things for clear objectives and goals, right? So it's like most software that actually has a meaningful goal in the context of a system tends to want to be delivered to someone. So it's about making software available for use. A really simple example of making software available for use is actually the fact that on your CSE machine, if you actually SSH, when you log into VLab, you're already logged in, but if you either log onto VLab and open a terminal, or you SSH into your own CSE machine, there's actually a folder that's been created in all of your accounts. One sec. Oops, I'm just getting rid of some stuff. Yeah, there's actually a folder. Yes. There is a folder like this in your account called public HTML. And if you go to that folder in your account, right, like you open VLab and you load that up, you can put stuff there such as, I'll make a file called COMP1531.txt. And I'll write, I love my COMP1531 students. And this is a file now that, say, if I open up something like this, I'm going to get an error. But the reason I'm getting an error here is because if you look at this URL up here, I'll just paste it into the terminal so it's a bit bigger. It's CGI, CSE, whatever, and then it's tilde my ZID and then the name of a file. So basically everything after this here is whatever's inside this public HTML folder. Now, the reason I can't view that right now is because if I look at the permissions of that file, you can actually see that that file, without getting into Unix permissions, because that's not part of this course, that file does not actually have the permissions for you to see it. So I'm going to change that quickly. And now you should be able to see it. So if you actually go to this URL, right, if you click, like I can paste it in the chat. It's like if you go to this URL, I don't know if it comes through on YouTube, probably, because it's my lecture, I guess. You will be able to load this page. Now, if you imagine that this is software, right? Text file, Python file, doesn't really matter. This is, like, you could argue that this is like the dumbest, simplest form of deployment, because I have taken software, shouldn't really call it software, let's make something more exciting, like page.html, that, you know. Wow, look how big this is. Let's call this software, right? An HTML file is so barely considered software, but if I want to make this available to people, it's like, I've just made it available to people. If that file's our software, or our binary's our software, I've now put it in a place where people can access it. Now, how do you make things available? We'll talk about that in a sec. Via the internet's the most common way, but this is making it available. It's a very dumb, archaic way of making it available, because what happens if I want to change this file now, or I want to work on it? I might have to make a copy of it and then fix it up and then like copy it back on top of itself, because everyone's going to be using this URL, right? Like all of the COMP1531 students are going to be coming back to this page every day now. So I have to be careful. I can't just go and change it haphazardly. So, you know, typically you're more working on a file elsewhere, and then you're, you know, making it available for use. So for example, let's say I copy this file back a folder into my home directory. So now I'm in my home directory, and I want to work on that file. I might edit this and I might add some more stuff that's like, added a new feature, 2 lines of HTML, like this, right? That's my file I'm working on, but you see the website is actually no different. That's because, you know, what's been deployed, what's been made available for use to you is different from what I'm working on. So how do I deploy this? How do I make this available to you? Well, I actually can literally just copy the file into the public HTML folder on top of my previous file. This, you could argue, is the dumbest, simplest form of deployment. Deploy. I've made my software available for use. Now you can see that. That's what this topic's about, literally, except there's just substantially more complex and variable ways of dealing with this. So, back to the deck. Let's talk about, you know, how we kind of got to this point. So, historically, software deployment was not really a very frequently occurring process. People would work on code for days at a time. You know, they test it for weeks. They go sit, you know, down in their office. And a big part of this was the fact that historically, software wasn't really... software was often like a physical asset, in the sense that if you wanted to give software to someone, you know, it could predate thumb drives, could USB drives, it could predate CDs even. You often had to put it on something and give it to someone. You think about, you know, even just movies, video stores and all of that kind of stuff. You think about getting Windows CDs in the mail. You get like, oh, I have the new version of Windows, or even video games now. I haven't bought a video game in, I don't know, 12 years. So like, I don't even know. I assume you just download them now, right? Except I think I have seen a lot of video games, you still buy them in the store, or like, if you buy them in the store, it's like you open it and it's just like a URL or something. I don't know. I have a couple friends who, like, I know there's all the online stuff like Steam and Game Pass and stuff, but like you can still, EB Games exists, right? What does EB Games even sell anymore? Do they sell, what do they sell? It's not CDs, right? I haven't thought about this in a decade, and it's just kind of messing with me now. Someone will tell me, no doubt, in the chat, so we can move on. You know, historically, that's what happened. Like, you think about a video game. They just used to release a video game, right? It was just, here's the video game, and then that was it. Forever. You know? And people would, like, play it. You know, there's like a whole subgenre, for instance, of people trying to break a game from, I don't know, 1999 or whenever, 1996, because they released it and there was bugs in it. And people have been exploiting those bugs for decades, right? Because that was just how they did it. So making software available for use in the past is, different, because you wouldn't really have this kind of iterative approach like you have with your project and stuff. So two major things happened in the last 10 years. One was the increased prevalence of web-based applications, right? So again, you think about what used to happen, or I should say network-based applications more than web. You used to have this thing all this time ago where you would get Windows on a CD, but maybe you would download Chrome or Firefox from the internet. Maybe you download some other kind of application from the internet. And you probably, I hope many of you aren't so young you don't remember this, but this happened, this is for me in like late high school, early uni, so I'm assuming for you it's kind of still in your like, puberty years, I guess. But you would have some things you'd have to get physically and many things you could download, right? The other big thing that happened was that there was a massive improvement to like internet connectivity, speed and bandwidth. Have any of you ever gotten an iPhone update? Have you any Android up? Maybe iPhones don't show you because they don't like sharing stuff. But like, if you get an Android update, it says something like, we need to install the new version of Android. And then it's like 500 megabytes. 500 megabytes is like what's on a CD that you used to like buy, right? It's a massive amount. And 10 years ago, trying to download 500 megabytes was a big, tall order. It just wasn't something you were going to do a lot of the time. Maybe like 10 or 12 or 15 years. 10 maybe it's okay. But so these two things kind of came together in the sense that because more and more things could be passed on through the internet, and because the internet had more and more bandwidth to send data through, suddenly a lot of companies started realizing that they can pretty much send all software rather than as an asset. They can send it out. Well, they can send it out as like a digital asset, right? You can download a game like that. And this spurred on an entire movement where so much of this topic and canon and literature around deployment comes from, which is this idea that you are no longer inhibited by how often you can push software out a lot of the time. You can quite literally update your code and push out a new version of it all the time. If you're UNSW, of course, you need an hour to do that. I don't know why. I don't know why they still go down for an hour every night between 12:45 and 1:45. I've said this, like, they're probably, I don't know what they're doing in that time. They're probably deploying, is what I've always just assumed they're doing. They're doing like their daily update. I don't know if they do work on it every day. I just don't know. It's just, the UNSW thing, it just interests me because I just distinctively remember my first year of uni, 2012, and they took it down for an hour at night. And even back then I was like, that's a bit dramatic. Oh well, at least they'll probably advance their systems in the next year or two. And here we are in 2022 nearly, and we're still going down every night for an hour. So, so there was just a lot more happened in terms of bandwidth and the ability to send software out. You download most things now. You can upgrade Windows 11 just by downloading it, essentially. So it's a big change. Another thing that happened naturally was also software as a service. So previously, in terms of deployment as a topic, it wasn't really a big topic again, because even if you were down, like, I have a CD here, but let's say, you move past CDs and you went into the world of downloading a file. Like you download, you can actually download Windows now. Cool. So Windows can maybe, ship out a few updates, but you still have to download it and install it. The idea is they were actually still sending you assets, in a sense, right? Like they were actually being like, here is the file. And this kind of happens sometimes when you download like Chrome or Safari or Firefox or something, is you'll see it's an actual like whole install file. And one thing that's really interesting is if you download, certain files and it's like 100 megabytes, it's typically because you're installing the whole program, right? Like there's a fun program I love called Audacity. It's a music, I don't know what you call it. It's not the website. Audacity, free, open source, cross-platform audio software. It's really fun. I use it all the time. You ever do the thing where you want to listen to music, like a song you like, but you want to listen to like a slowed down version of it because it's chill? You can use this for that. Anyway, it's like, this is a software, you download the whole thing, it's like a big file, you install it, and it's kind of installed, right? And you can get it over the internet, but what also started to happen that's really ramped up this whole world of deployment being a big topic is the idea of software being shipped as a service. This first started happening with things like web browsers, right? For as long as I'm sure you can remember, web browsers used to update themselves, right? Your web browser needs to update. Chrome needs to update. That's been happening for God knows how long. Then, ever since the release of the iPhone, a very similar thing started happening with phones, right? You've never had to install an operating system on your phone, have you? It's just been there and you just get the software updates. So as an operating system, phones were quite pivotal in the sense that you could just have a phone and it would just, like a service, like someone is just servicing your car or whatever, just update itself. And then eventually operating systems on laptops and desktops moved into that category too. We started getting things like Netflix, where you pay per month. You're not getting assets anymore. You just, you're just like paying per month and they're just giving you stuff. And Netflix is updating every day, right? Like they're probably making fixes all the time. They're adding new things. They're just constantly making newer and newer versions of it available for use on like a daily basis. Same kind of thing happens with OSs now, like Windows 11, Windows 10. You just get sent updates. So all of these things accumulate to the same point, which is that most software you use now is coded over here and released very regularly to people, which is very different from 15 years ago. When you release software to people, because of the web nowadays, it's not like most software that you write is not released the same way that things like Windows and Chrome are released, which kind of is where this lecture takes a slight pivot. So some of the examples I've given here, like your iPhone and Android and laptops and stuff, they're a little bit different and they're a bit of an edge case, because in all of those cases, you are taking software and you are essentially sending it out to millions of people's devices. The more common way that we all interact with deployment these days is that we're actually taking our code and pushing it up to a cloud provider who is where everyone kind of accesses it, right? And that's the most common way many of you will interact with this environment, because it's not like you're writing code that you need to send out to a billion iPhones. You're going to be writing code that ends up on some kind of service a lot of the time, like AWS or Heroku or Azure, Google App Engine. Every big company's got one of these, like Always Data for your project, and then everyone else accesses that. So this is the big web network bandwidth revolution, is now anyone can take code, make it available for use on a service somewhere as an abstraction, and lots of people can access it. Now, how this fits into modern deployment, which is why the slide was the wrong way around before, is that deployment is very complicated. It's not like what I showed before where you just copy a file across. There's often a lot of steps involved in it, which is really what today's lecture is about. How this fits into the pipeline, though, is it's essentially a step that occurs after continuous integration, which we have already talked about. So we know from week 3, I can't remember, week 3, I think it was, that continuous integration is the process of, like building and testing and linting your code, and it's integrating code changes. It's basically letting you merge code into master and making sure that it still works, right? That's the integration part. The deployment part is where you say, all right, well, our code on master has passed our pipelines. Now it's time to make it available for use, and to do so in an automated way, because most deployment, as I said, is very complicated. There's a lot of steps to go through. And like, think about Always Data, for example. Like, there's a lot of these manual, if any of you have tried it out, because I know a few of you have, and maybe when you're watching this lecture later, you've tried it out by then. It's a lot of like, SSH and SCP and copying files, and it's just like, it's something that you're going to screw up eventually if you keep doing it like that. I mean, not that that's a bad thing for the project. I mean, like in a real world environment. So most deployment is automated, and totally integrated and totally out. Like, you don't have to do much at all, because you kind of set it up to be automated, just like the GitLab pipelines, right? You just push it and it just automatically does it. And we're talking about the same thing now, but in the context of, deployment. Now, we know what continuous integration is. We just talked about it. It's a little circly thing. Continuous delivery, though, which is the automation of deployment, is essentially where you can allow accepted code changes that have been correctly integrated as part of continuous integration. You take those accepted code changes and you deploy it to customers, users, whoever, people who want to use your software quickly and sustainably. And often, this involves the automation of the release process, but you still actually have to press a button. So continuous delivery, in summary, big red button, you click it, what's on your master branch goes out to everyone who uses your software. Or more specifically, it goes out to some kind of server where everyone accesses your software through. Because you think about most big companies, Google, Facebook, Atlassian, Canva in Sydney, Dropbox, all of these companies are most of the time web-based, and they're making their software available through the web. How often do they make it available? This totally depends on various companies, and the processes here are really company dependent, though you can generalize them pretty simple, which is that many of them have a big button, and that big button will automate the release of things. Some of them will send software out daily or weekly or monthly, right? Android probably doesn't send software out to you that often because it's a lot to download, and the kind of dynamics of making software available to you on your phone personally are very different from the internet. But I imagine most large companies, Atlassian, Google, Facebook, they're doing this daily. They're giving you new code every day in some way. Often there'll be very small changes. There's often some kind of sign-off process, particularly for smaller companies or small to medium companies, because they're going to have less automated processes in place where someone kind of needs to say, yes, big red button, click. And the reason we automate it is so that people, people make mistakes less, because you're going to make a mistake, right? If you're following some kind of manual instructions, you'll eventually make a mistake. Waleed says, how often do I do this at work? We do it every day. Typically 11:30 at night. I can't remember the exact time, but it's something like that. Yeah. And this is how continuous integration and continuous delivery fit together, right? You plan your code, you code, it builds, it tests, you go through that process until it's good, and then once it's good, you go through the release process where it actually, gets released and sent out to users like that. You can read more about continuous delivery on Atlassian's site or GitLab's site. They're both big fans of Git, so continuous integration and continuous delivery are big parts of reasons you use Git, Why would you ever use something like Git in the future? It's because there's a lot of tools that allow you to kind of easily deploy this stuff. And in fact, if you knew how, and I won't lie, I've never tried to do it, so I couldn't tell you exactly, you could automate your code. You could go and update your GitLab CI file on GitLab for your project to every time it passes the tests, every time it passes the pipeline on master, to automatically deploy it to the always data site. Right? So for iteration 3, we've said we want you to manually deploy it once. We just want to see it manually deployed once, so we know you have one of you has at least gone through the process. But you could actually automate that, right? The step you do to deploy it, you could put that in the pipeline, modify the YAML file in some way. Gorb says you have to put in 2 keys to activate it. It's funny you say that, Gorb, because quite often it's what you tend to do is not so much put a lot of strictness around the deployment part, but you tend to put a lot of a strictness around the integration part, because if you put a ton of effort and energy into making sure that the only time something gets merged into master is when you are 100% sure that it's awesome and great, then you totally de-risk you don't totally de-risk. You substantially de-risk the deployment part. So a lot of the kind of emphasis on, triple checking everything, and this would definitely happen at bigger companies, is on the integration part. There's a point where they're like, yep, this particular commit on master is good. And then it's like, well, you can deploy it. If it's good, you can deploy it. It's not going to break anything. Max says, who tests for bugs before release? Do you think the releases before they're actually deployed Or do you rely on deploying bug fixes later? I mean, it's a bit of everything, right? Like every company out there has bugs. There's always things you're going to miss. There's always things tests are going to miss. But ideally, you want to get it all before the deployment stage. Rahul says, is the front end just HTML and CSS, or is it more than that? That's a complicated question. The short answer is that essentially it kind of acts like just an HTML, CSS, and JavaScript file. But we might talk about that next week because we have a bonus lecture on that. By the way, just on the bonus lectures for everyone who's watching, you probably might notice, again, the nature of this course is that we do push you very hard in the first few weeks to get a lot of the critical content out. And therefore, in the last few weeks, we can actually spend some more time talking about interesting things and bonus lectures and stuff. So hopefully that's still fun. Now, we kind of get the idea. You have code that's ready. You automate its release. And then it's released. You might do it every day. You might not. There's a big red button you hit that releases it. But what will often happen is that you'll have a different number of release methods, right? So an established organization, this is not something that any of you need to go and stress about, because you start a little pet project on the side and 3 people use it. You don't need to worry about this. Is release methods whereby you don't always want to go straight from your GitLab repo or your computer straight to a production environment that people are using. You often want to go through some kind of like interim testing period or testing process. WebCMS3 does this, for instance. There's a URL that you can access that's actually like WebCMS3's interim changes or their test changes before they release them. So when WebCMS3 has new features, they actually get put out on an interim site where people, like me and other staff can test it. And then they say, okay, no, they've tested it. That's all good. Now we can move it into production. How many of these do you have? Do you have 2 or many? It varies. Some companies would have dozens of them for different states of features. Some companies would just have 1 in production. I think a common kind of one I generally just say to people is you'll always have your production environment. That's where you've released it to. Then typically you're going to have some kind of staging test environment. Sometimes they'll call it a UAT environment, which if you think back to last week is user acceptance testing environment. It's the environment that you give it to users to check if you've done, made the right software. And you might have more than that as well. But typically there'll be some kind of interim stage here. Now again, this doesn't mean you all have to go away and do it, because I think one kind of trope of this entire conversation is that people come away from this saying they need to come up with this big infrastructure. Whereas in reality, if you're working on a small project, you can just you don't need anything other than a production environment. Because if you send something up that's wrong, and it breaks suddenly, you just upload the older thing and it'll go back to normal, and it wasn't working for 5 minutes and no one notices it because no one's really using it, right? So you don't have to over-engineer things. I've just kind of talked about this. This is just one way to think about it. Sometimes you do less or sometimes you do more. One interesting kind of case study that I think is interesting is Microsoft's flighting process, their ring theory. It's a funny word. Where basically I think they developed this for Windows when it came to Windows 10. Which was their first time they started releasing software as a service. Windows 10 was the first time they released software as a service. And what they actually do is that they have it's kind of weird to think about, right? You have Windows, it's an actual repo, right? Like it's a code base with a bunch of files in it. And what they actually do is they actually have a daily build of that. So every single day they build the Windows operating system into a thing. And that's available every single day. And what they do is that every so often, every time they think they hit a milestone or time passes or it passes some tests, I'm not sure what it is, they release it out to another ring. And as you move further and further out to various rings, in theory it becomes more stable because it's built less often, because the more built often ones are probably breaking all the time. So this is kind of like, imagine for a second that you have your master branch. And every single day that master branch gets kind of deployed somewhere onto a secret site, yourgroup.cse.unsw, and it's breaking all the time. That's like your canary, and then every week you get it all together and you say, yep, it's all good, and then you kind of would release it to the next ring. So this is an old diagram, by the way, so it's probably like somewhat outdated, but it's like you can see here, it's like they have various rings such as like daily builds, all the people that work in Windows that want to have it, and then like later on it's the entirety of Microsoft. So you see this a lot at big companies, right? Is that everyone at Microsoft probably has I say probably because I'm just speculating with some of these things. They probably have an earlier, like they have a newer version of Windows than you'll ever have because they're getting it before it's released out to everyone else. Because they want 50,000 engineers to see this stuff so that everyone's helping report bugs, right? Because it's better that 50,000 paid staff are reporting bugs than you and me. But also, if anyone here has ever been interested, you can actually get earlier versions of Windows than the general public by just going and subscribing. They actually have ways out there where you can say, I want the newest stuff, and I know it might break sometimes, but I want it. So you have your Windows Inside is fast and Windows Inside is slow and release preview. That's why these are colored differently. And they're for the general public. And I have friends like this who they really want some new feature on Windows and they're like, oh, I'm going to get on that. And they get the more frequent updates, but then their computer just randomly crashes every couple of days because there's bugs in it still. And it's quite a rigorous process. So this release method is an example of how, you're still making software available for use, but you do it in a staged and controlled way. Now, one of the last things here is continuous deployment. Continuous deployment is basically just continuous delivery where the decision to go towards production is automated. That's it. There's no big red button. The computers control the big red button. Basically, it's if you pass all the tests, what decision is there to make? How are we gonna what's the person just gonna stand there and click the button because the computer said to click the button? The computer might as well click the button. So this is just a terminology thing that's what's the difference between continuous deployment and continuous delivery? Continuous delivery is the automation of things, but the actual release step is manual. Continuous deployment is an automated release process, and you can read more about continuous delivery and stuff there. Now, in terms of your project, there is a free service I found because many of these cloud providers have services, but they either cost money or they'll ask for your credit card and say we're free until you use too much. And I'm not going to ask 900 students to enter a credit card to do an assignment, even if it doesn't cost them anything, because I understand the problems with that. So there's this French company, I think, called Always Data. I think it's European, which is free for small projects. And there's a link in the project about, I did a pre-recorded video a year ago, I think, when we first introduced this, the kind of steps you through it, and it's going to be a bit bumpy, right? I think I've said this to students last time as well for the iteration 3 demo, was the thing about the deployment we've given you is it's really just to give someone, at least someone, ideally more of you in your group, a feel for what these kinds of tools are, because most deployment is using a tool to release your software to. So we're just trying to get you comfortable with it. But, there'll be problems. It just won't work. And you see this already with groups on the forum. And it's not like code where you kind of come to us and you say, I've got this problem, fix it for me. Because it's the challenge here is actually just using the tool correctly. It's like assembling a table, right? You think about a piece of IKEA furniture. There's no challenge to it. You just follow the instructions, right? And occasionally you misinterpret a step or you miss a step and then it doesn't come together and you have to go back and start. That's the experience of this tiny part of the project. Now, the last couple things we have to talk about today are a concept called Devops, which I think is important for everyone to be familiar with. In the past, people used to write code, people used to test code, and people used to be focused on, deploying code and maintaining it. That becomes less and less of a thing these days because there's an expectation in general that those things all overlap a little bit. As in, you can't just be like an IT system admin who knows how to run a server or build a computer. You need to be someone who understands a bit of engineering. And engineers need to have a sense often of, what's actually happening with the deployment side. That's that one a little less true. But as part of that, there are these roles that have started to develop in most companies called Devops roles. And you could think of them like deployment roles, might be a way to think about it. But essentially, it's where there's so many different ways you can interpret this. So I don't want to be like, I'm not trying to be prescriptive about it and be like, this is what the role is. But DevOps just broadly is a term that's used to describe someone who can help connect things together, right? Like you think about mechatronics engineering, where they're like, mechatronics engineering, it's like the software and electrical and the mechanical, and we're going to build robots together. DevOps is, as a notion, as an idea of like, well, we got some software and some testing and some deploying, and we have to make it happen. And a lot of people who are in these DevOps roles these days, development operations, tend to be people who are quite often engineers, but they spend a lot of their time kind of administering and managing these services like AWS or Azure or Google App Center, whatever it's called, etc. So it's a kind of word you'll hear a bit more of. So if you see kind of a DevOps role, it's like, often they'll expect you to have an engineering background, but the focus on it will be, tell us how you've used AWS before. Tell us the application, tell us how you scaled an application. And that's a whole topic in itself that, generally speaking, I'm trying to see if CSE can get more integrated into it. But it's hard too, because it's a relatively new topic. 5, 6, 7 years ago, people just weren't using these big software giants as much. And if you look around, you have all these old companies like Telstra and everything else who, for the longest time, still had their own servers. And now everyone's moving to the cloud, right? Everyone's moving off these things. All these new companies have never even managed their own stuff. They've been running on the cloud from day one. You think of Atlassian, right? I don't know the history of Atlassian, but I'm sure 20 years ago when they were founded, their earliest software would have been hosted on servers they ran. They probably had them in an office somewhere. Nowadays, I think Atlassian's mostly moved to the cloud. So you need people to actually manage that process of how software integrates with the cloud. Now, the very last thing on this topic is, in the SDLC, we have this maintenance topic at the end. We don't talk about it in this course, but I did just want to mention it briefly because it is important, even though we don't go into any depth with it. Maintenance is kind of what happens after you deploy. So you deploy your software, so you figure it out, you design it, build it, test it, deploy it. It's out there now. What do? You don't go to sleep. You learn, right? So as part of that, the second it's deployed, you're immediately going to be thinking, what do I do next? How do we improve it next? And there's a whole thing to do. You can go and interview customers and stuff, but there's a very kind of methodical, technical, somewhat quantitative approach as well, which is just monitoring your software. We will talk about this a little bit in week 10, I think, but, think about your Flask server being out there on the internet. You can monitor how many 404 errors there are, how many 500 errors there are. Maybe people are trying to interact with your Flask server and they're getting all these 404s, so you want to monitor that and maintain it and be like, 10% of the requests are 404s. Why are they 404s? Then you see that someone's calling a URL route that you got rid of that you used to have, and you think, we need to redirect it. I'll fix up the PDFs. Thanks, Sulux. And then also enhancing user experience, right? How do we learn from what our users are doing? And we're going to talk about that a little bit more in week 10. Not in much depth again, because it's not really part of the course. It's more just trying to tie off that circle, because I'd hate to give you a circle and be like, this is really important, and then just pretend one of them doesn't exist. But it's a lot of monitoring and analyzing, and this is also falls into that kind of DevOps role too. So if you have a DevOps engineer, they're going to often be the first people who are noticing that disk usage is really high. So for example, let's say that you have an infinite loop in your software under some conditions. You don't notice that during testing because you only test so many things, and you're a human like me. that happens. So you deploy it, and now 1,000 people an hour are using it, and then one of those users runs into a random use case that you didn't expect, and then they start getting into an infinite loop, and your server's just like literally shaking. What's going to happen is you're going to monitor the disk usage and stuff, and it's going to, it's going to be really high, or the memory usage, or the CPU usage, or something will be really, really high. So this kind of whole topic you always hear about scaling and all this stuff, I mean, most of it all falls into this bucket of stuff we've talked about today, where it's all in the realm of how do you make software available for use. And when anyone says scaling, they're really just saying, how do we make it available for use for more people at the same time? Because that often needs different kinds of software, or, different systems in place. That pretty much brings us to the end today. Does Flask have built-in monitoring tools? Blake says. I don't know. There's a lot of cool services out there that I would recommend a lot of you check out. I showed you back in week 3 a continuous integration pipeline that we have at work. Where I showed you like the different steps in that pipeline. I'd maybe just quickly touch base on that again to explain like where the deployment part comes into it too. So like, I'll just pull this back up because this is on GitLab here. Sorry, this is on Bitbucket. So here's an example of a continuous integration, continuous deployment pipeline that uses AWS. So GitLab, GitHub, Bitbucket tend to do a lot of the continuous integration, and then they tend to deploy it out to a cloud service like Google, Microsoft, Amazon server, typically are the 3 big ones. You can see here that this first part, this linting and testing, is all the stuff we talked about back in week 3. It's doing like a pip3 in different language, not Python. Pip3 installs, it's doing some linting, it's doing some type checking, which we'll talk about next week. And it's testing it, and it's testing that the database is working and all this kind of stuff. And then once this passes, it'll say, okay, I'm now ready to send it to the cloud for deployment. So it gets zipped up, all the files get zipped up into one place, and then it gets uploaded to an AWS service. There's lots of services out there that all do the same thing. And then what happens is there's like a certain series of like kind of commands that are triggered that are like, now we're going to deploy it to a testing server. And then afterwards we'll deploy it to a production server. And maybe that's a manual process. So this is kind of like how this continuous integration, continuous deployment, delivery stuff goes. Is you do your CI, you have your CD, and it's sending it off to cloud services. And Bitbucket, which is the same as GitLab here, it's not doing the deployment stuff, it's just getting it ready and sending it off to something else, which in this case is AWS. And that's a whole other system. And AWS is like Always Data. Heroku is really popular as a service, I believe, for like kind of personal projects and whatnot, just because it's relatively simple. Comparatively, like AWS is like is a beast of a thing, and not all in good ways. It's less abstracted. It's so much detail everywhere. It's relatively not the best documented from what I can tell. So Heroku's a really popular one for kind of people like yourselves who are just like, oh, I made a Flask server, I want to put it on the internet. Check out Heroku probably. There's no doubt others. I hadn't heard of this a year ago or two, so it always changes. Anyway, that's pretty much the end for today. If you could leave feedback for today's lecture as well, that would be great. Waleed asked before, how often do people leave feedback? Not many of you do. I maybe at the start of the first lecture, it was like 200 people fill it in, and then by week 3, it's like 7 of you do it. It's subsampling to the max, but I still value the feedback because you can actually draw general conclusions from it. I just try and make it relatively simple. Remember that Jake is taking the first hour of the lecture tomorrow. It's a bonus lecture on classes. So if you don't turn up or you don't watch it, nothing bad's going to happen to you. You could skip it if you want to. Then for the second hour from 10 to 11 Sydney time, I'm doing a lecture on property-based testing, which is a pretty light lecture. I can't imagine us talking about it for an hour, but we'll see how we go. So have a great day. Remember, GitLab's down till 5 p.m. So people with Wednesday classes, GitLab's down. I have given tutors copies of your work. I managed to grab all of your labs off today before GitLab went down. So they have copies of your work so you can still get marked off. And yeah, have a great day. I'll see you all tomorrow or the next lecture if you're watching these in a binge, you poor thing.